Hello everyone, welcome back to our channel. Let's see the next part of CHEMDRAW. In this part, we are going to have a discussion on structure determination of organic compounds by using spectral techniques. We all know that four techniques are generally useful for the structural determination of organic compounds. What are those? UV visible spectroscopy, IR spectroscopy, NMR spectroscopy, and mass spectrometry. These are the four techniques generally we will be using for the structural determination of organic compounds. Among the four techniques, very important two techniques are mass spectrometry and NMR, nuclear magnetic resonance spectroscopy. In NMR, we need to have the data of two types, proton NMR data and C13 NMR data. If you know the data of these three spectral techniques, 99% chances are there you can identify the structure of your compound. So let's discuss how can we collect the data of mass spectrometry, proton NMR and C13 NMR by using the CHEMDRAW software. So let's take one example. For that purpose, here is the molecule, that is metachlorobenzoic acid. One simple example we are going to take for the purpose. So metachlorobenzoic acid means benzene ring containing one COOH group and one chlorine. This is metachlorobenzoic acid. So in the first part, we studied that whenever you draw a particular chemical molecule, what is the first thing we need to do? We need to select that molecule and go to the file and activate the option apply document settings from using ACS document 1996. Thereby what happens? The structure is going to be in the standard format. Okay, so this is the standard structure of metachlorobenzoic acid. Okay, for the explaining purpose, I am going to change the scale setting. Okay, for the visibility purpose only, I am doing like this only. Okay, now let's see the data of this particular molecule using the spectral techniques. Let's see the first one, that is the mass spectral technique. What is the mass spectral data of this molecule? Okay, how can we retrieve the data related to mass spectral? For that purpose, what you need to do, simply select the molecule by using lasso or structure perspective. You can use any one of this one for the selection of the molecule. So we have selected the molecule, then go to the option called as view, the indent view. In that, activate show analysis window. This one you need to activate, show analysis window. See here what happens, one window is appeared or not. This data is related to mass spectral analysis. Already we know that what is the main aim of the mass spectrometry. The mass spectrometry is useful for the identification of molecular weight of the substance. Whenever you know the molecular weight, thereby we can determine the molecular formula of the compound. If you know the molecular formula, automatically you can get the remaining information. If you have the molecular formula, then what should we collect? The elemental analysis. What is the percentage of element which is present in the molecule? So let's see. The first one is, this structure is having the molecular formula C7H5ClO2. So what is the molecular weight? 156.565. Here you can change the decimals also. Here three decimals are there. If you want to reduce it, you can reduce. Okay. So in this way, you can get the decimals also. So by using this one, we are getting molecular formula. Second one, molecular weight. We all know that whenever you see the spectra of mass, what we will observe? We will observe some particular lines. That lines is indicating m by z on x-axis and intensity on y-axis. So mass by charge ratio of species of ions we will get. We know that the mass spectral technique is useful for the identification of positively charged ions only. So what kind of positively charged ions we will observe during the mass analysis? One is the cation, second one is the radical cation. For more details, go to my channel and listen the videos which are related to the mass spectrometry technique. Okay, so if you observe the m by z values, how many values we are getting? Three values are not. It means we will get three peaks. One peak is at a high intensity, remaining two are at the lower intensity. 156 is the highest intensity. This peak is called as molecular ion peak. Okay, so based on the molecular formulae, we are getting percentage of each element in this particular compound. Okay, for example, assume that you have synthesized metachlorobenzoic acid in your laboratory, right? You want to confirm that by using the chemical methods and spectral methods. By using the chemical method, what should you identify? The presence of carboxylic acid group, the presence of aromatic ring, and the presence of chlorine. By using the chemical method, we can identify these three portions. So if you want to get the more information, we need to have spectral data. So for among the different spectral technique, the first one is mass spectral technique. So by using the mass analysis, we will get this kind of data. Now, you have synthesized your compound in the laboratory. Okay, you have sent the sample for the mass analysis. Okay, so you will get the data, you will get the mass spectra. Then the question is, how can you interpret that spectra? In order to interpret that spectra, we can use this data. This data can be available by using the CHEMDRAW software or not. Simply what should you do? You need to draw the structure of the molecule, select the molecule, go to the view option and activate analysis. You will get complete data. Now compare this data with your real data. If the real data is matching with this data, then you can confirm that your compound is formed. Okay, so in this way, you can get the molecular formulae, molecular weight, and different peaks, and also the elemental analysis. Okay, so this is the one portion. Okay, now go to the second one, NMR, nuclear magnetic resonance spectroscopy technique. We all know that among all kinds of the spectral techniques, NMR technique plays a very important role in the structural determination of organic compounds. So we have two types of NMR, proton NMR and C13 NMR. For more details regarding the NMR spectra, so go to my channel and watch all the videos which are related to the NMR. Okay, now let's see how can we get the data of proton NMR. So in order to identify the proton NMR spectra of this molecule, first we need to identify what are the different kinds of protons which are present in the molecule, right? So in this molecule we cannot see the protons. For identification purpose, just I am representing the protons. This is for understanding purpose only. Here is one hydrogen, here is one hydrogen, here is one hydrogen, here is one hydrogen. Before the interpretation of any spectra, first you need to understand the equivalency and non-equivalency sets of protons, right? So see the first video in NMR in my channel. You will get the complete data related to chemical equivalency and non-equivalency. This is the disubstituted benzene. So two different groups are present. So because of the two different groups, the all protons environments is going to be different. That's why all protons are chemically non-equivalent. So this will be considered as a one proton, Ha we can say. So how can I get the subscript? What should I do? I need to select the A and click X2. You will get subscript. So this will become Hb, different proton. Select and X2. This will become Hc. Select and X2. This will become Hd. So these are the four different protons. And this one is also one different proton or not? Having different environment. That's why this is some He, you can say. So 1, 2, 3, 4, 5 different protons are present in the molecule. So if you have the 5 different protons means you will get 5 different peaks or not. So you will get 5 different peaks. But in order to bring the spectra, you should not represent the protons in this way. So directly you should represent the general protons. For your understanding purpose only, I have written these details. So you have 5 different protons in the molecule. Okay. Now select this molecule, go to the structure and activate predict proton NMR shifts. Click this one. See what happens. Here you are getting different chemical shift values or not. Already we know that in NMR we will get the data in the form of chemical shift. Already we know that the carboxylic acid protons are having the delta chemical shift values in between 11 to 13. So this is 12.74. In case of the benzene ring, we are going to get the data in between 6.5 to 8. So here see the benzene protons. The benzene protons are having different chemical shift values. So this is the spectra we are getting. So you have synthesized metachlorobenzoic acid in your laboratory. You have sent the molecule for the proton NMR analysis. You have received the spectra. Then how can you identify whether your compound is formed or not according to proton NMR? For easy understanding, what should you do? Simply you can draw the structure of the compound in camera, select it, go to structure and activate predict proton NMR shifts. You will get the data. So whenever this data is matches with your original compound, then you can say that your compound is formed. So in this way, the theoretical spectral data helps in the interpretation of the compound structure. Okay. So in this way you will get the data. Here see, for your understanding, all kinds of protons are mentioned here. Right. Suppose if you are not identifying from here you can identify. Okay. So in this way you can get the proton NMR data of certain chemical compounds. Let's see the C13 NMR data. In case of C13, what is the molecule? Metachlorobenzoic acid, ClCOOH. This is the molecule, right? So in order to get the data, what should you do? You need to select the structure. Again, go to the structure option and now activate predict C13 NMR shifts. So before clicking the predict C13 NMR shifts, you need to identify C13 NMR means we can identify the C13 nucleus. How many carbons are present in the molecule need to be identified by C13 NMR spectra, right? If you observe this one, we have 6 carbons in the benzene ring. All 6 carbons are chemically non-equivalent or not? Why? Because this one is connected to COOH, this one is connected to Cl, this is in between, this one is ortho, this one is meta. That's why all carbons are chemically non-equivalent. So all carbons will get different chemical shift values. So 6 carbons here and 1 is carboxylic carbon. So total 7 non-equivalent carbons are there. So you will get 7 different C13 NMR peaks. So select the structure, go to the structure option and activate predict C13 NMR shifts. See 130.3, 134.2, 134, 133, 130.0, 128.4. This carbon 131.6 and this carbon 165.1. So these are all carbon chemical shift values. This is the spectra we are getting. So these are the details. Now you can compare the details of the theoretical C13 NMR spectra of metachlorobenzoic acid with your original compound. Simply, this data will help you in the interpretation of the structure of your original compound. It's not like that whatever the data is available here, exactly you will get the same. No, you will get the nearby values. Assume that it is 165.1, so you will get 165 or 164.9 or 165.2, like that. If it is 130.3, you can get 130.1, 130.2, 129.9, like that you will get the data. Okay, so the fraction is going to be ignored. Okay, so in this way, the theoretical interpretation of this data will help you in the identification of your unknown chemical compound. Okay, so we will continue the CHEMDRAW and discuss the remaining portions in the next video. Thank you.